So in this example, we're going to talk about angle of elevation again, but we're going to address this. It's going to end up looking just a little bit different from the previous one we've looked at. In this problem, it says Marla needs to find the height of a building. From a given point on the ground, she finds that the angle of elevation to the top of the building is 74.2 degrees. She then walks back 35 feet. From this second point, the angle of elevation to the top of the building is 51.8 degrees. We want to find out what the height of the building is. So again, we don't have a picture that's drawn, so we're going to go ahead and draw the picture representing the description that was given to us. We know that we have some building here that is a height. That's ultimately what we want to find. From the second sentence here, it says, from a given point on the ground, she finds that the angle of elevation is 74.2. Okay, so we have some value here on the ground. And we know that that angle of elevation, remember the angle of elevation is based on your line of sight horizontal to the ground. So we have, oops, that was probably not a great line. Let's try that again. We have this angle here. We know that that angle is 74.2 degrees, but I don't know how far we are from the base of the building to this point. So I'm going to call that X. Now the next part says she then walks back 35 feet. So she's walking back 35 feet from where she was. So we're going to go 35 feet here. So this is now from here to here, 35 feet. And from that second point, the angle of elevation to the top is 51.8. So let's see if I can draw a line. This didn't make it. We'll try it again. There. So from here, we are 51.8 degrees for my angle of elevation. And both of these are reaching the top of the building over there. We want to ultimately find out what the height of the building is. Now, we have, in essence, one triangle here from the first point she was standing on that we can kind of see represented by maybe this green triangle. And then we have the second, so we have this green triangle here. Then we have a second triangle that we have represented by, let's call it the purple triangle. And in both of these cases, we have a measurement here along the ground. So we would have maybe the leg of a triangle, let's say, along with an angle of rotation. Ultimately, we want to find out what the other leg of this triangle is. Anytime we have this case where I have an angle, an adjacent side, and I'm looking for an opposite side, then we are technically going to be using tangent. So I have two different equations that I can set up here. The first equation, let's look at the green triangle. In this green triangle here, we can say the tangent of 74.2 degrees would be equal to opposite over adjacent, right? So 74.2 degrees would be equal to the height of the building over this distance that she walked. Now, the second triangle that we have here says that I have the tangent of 51.8 degrees would be equal to, again, the height of the building over this total distance, which would be x plus 35. Now, if I'm ultimately trying to find out what the height of the building is, I need to recognize here that I have two equations. Okay, both equations have height in their numerator of their fractions. So let's solve both equations here for the h. In the purple equation, we can solve this. We can say that h would be equal to x plus 35 times the tangent of 51.8. And in the green equation over here, we would have h equal to x times the tangent of 74.2 degrees. Notice that in both cases, our h's are equal to some value, right? Well, they're both value, I guess, would be equal to the same h would be a different way to phrase that. So if both of these expressions on the right-hand side of the equation are equal to the same value of h, then we can technically set both equations equal to each other and solve for this value of x. So what that looks like is we have x plus 35 times the tangent of 51.8 is equal to x times the tangent of 74.2, because both of these expressions again are equal to the exact same height. We can set the expressions equal to each other. Now we want to gather the variables up on the same side. So we need to first get rid of our parentheses here, distribute, right? So we're going to take tangent of 51.8, that's just some number, I don't know what it is yet, and I'm going to distribute it into this set of parentheses. So I have x times the tangent of 51.8 plus 35 times the tangent of 51.8 is equal to x times the tangent of 74.2. So now we do want to gather the x's on the left. So I'm going to take x tan 51.8 minus x tan 74.2 is equal to, and we're going to take this 35 tan and subtract it to the right, minus 35 tan of 51.8. So here we have a lot of tangents in here, but that's okay. Notice that in the left-hand side, I've got x times some number minus x times a different number. So I have a GCF, I have a common factor x I can take out. So I have x factored out, leaving me with the tangent of 51.8 minus the tangent of 74.2 equals the right-hand side, negative 35 tan 51.8. We're trying to get x by itself, so we would divide both sides by whatever's in this parentheses. Tangent 51.8 minus tangent 74.2, divide both sides by that number. Tangent 51.8 minus tangent 74.2. So it's this component here, 35 tan 51 over 8, divided by the denominator here that I'm going to plug into my calculator. And let's just pull that up and see what that looks like. So from here, we have negative 35 times the tangent, let's scoot this over a little bit, times the tangent. Okay, so we'll try that again because I had my calculator in the wrong mode. So we're going to take negative 35 times the tangent of 51.8. And that you can see there. And then I've got the denominator here, so I'm going to take the tangent of 51.8 minus the tangent of 74.2, and I get a value, and I'll divide negative 44 by negative 2. Oops, we need a division sign in there. And we find out that x is equal to 19.65. So we know that x is equal to 19, we'll call it 19.7. So let's go back up here and think about what we found. We know that x is now 19.7, but I don't know what the height is. I just know what x is. But I can come back to one of these expressions that we had here, and let's choose the green one because it's the smaller of the two. And so we're going to come down here and we're going to say, okay, well, don't forget that the height of the building is equal to whatever x was, which we found to be 19.7, times the tangent of that angle of elevation, 74.2. And when we plug that into the calculator, we find 19 times the tangent of, we'll say 19 times the tangent of 74.2, and we get a height of the building being 69.5. So 69.5 feet is what we determined the height of the building was. 69.5 feet. So it's a little bit of a longer problem, obviously, with angle of elevation, but we were able to use these two triangles and understand that they both gave me an angle of elevation to the same location of the height of the building and set those two expressions equal to each other.